Hello everyone. So welcome to the very first lesson of physical sciences. So kule lesson sizabe sidiscussa topic momentum and impulse, right? So as an introduction, bonuguti, it's best to look at the important definitions in this topic. So in this lesson, sizobe define the important terms and then discuss impulse, conservation of momentum, and kinetic energy. And then after maybe do a few examples, right? So ama-definition engisowasebenzisa are those ones from the exam guidelines. Ngik-advise ukuthi usebenzise ama-definitions aphuma kuma-exam guidelines because mostly ilama definition lawa abawasebenzisako naku-memorandum. So kuyenzeka ukuthi i-textbook i-define let's say momentum in a different way as bayidefine la kuma-exam guidelines. So to be on the safe side kungcono ukuthi usebenzise ama-definition lawa abawasebenzisa kuma-exam guidelines, right? So as an introduction, we can maybe just read through the definitions. So sizocala momentum, sicale the Newton's second law of motion in terms of momentum, and then sicale impulse and the conservation of momentum in elastic and inelastic collisions, right? So here they define momentum as the product of an object's mass and its velocity. Lokho kuchaza ukuthi if une mass ye-object and you know its velocity, you can calculate momentum by taking the product of the mass of that object and its velocity. So which takes us to this formula here. The formula in momentum, it's P is equals to mv, where m is the mass of an object and v it's the velocity of that object. So when you say that mass times the velocity, you get the momentum of that object, right? And then they say you can describe linear momentum of an object as a vector quantity with the same direction as the velocity of the object. So here they are saying momentum is a vector quantity, meaning it has both magnitude and direction. So you can remember from grade 10 the difference between scalars and vectors. A vector has both magnitude and direction. So in this case, a linear momentum of an object can be described as an object's mass and its velocity, as an object's mass times its velocity, right? Because a mass of an object is a scalar quantity, it only has magnitude. But a velocity of an object, it's a vector. It has magnitude and direction, right? So if city magnitude and direction, sichaza ukuthi okay, for example, ku-velocity we can say an object is moving at 10 meters per second to the right. The fact that we say to the right, lapho sesi-indicator i-direction, ne? So because sesi-indicator i-direction, kusitshela ukuthi that is a vector. So u-10 meters per second loya, it's the magnitude, right? So laba emphasize ukuthi momentum is the product of an object's mass and its velocity, right? And this is the formula to be used, and momentum is a vector quantity. Okay, so siyadlula lapho siya ku Newton's second law of motion in terms of momentum. So from grade 11 physics, you'd remember that the formula for the net force was defined as a product of an object's mass and it was defined as the product of mass and acceleration. So F net was equals to ma. So in this case, F net is equals to the rate of change in momentum. So formula leyo uzoyinterpreta njalo uzothi the net force exerted on an object is equals to the rate of change in momentum. So they state Newton's law of motion in terms of momentum by saying the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. If they ask you to state Newton's second law of motion in terms of momentum ku exam, you would write this definition, right? So another tip engakunikeza yona with ama exam, mina I sort of like made sure ukuthi if babuza i-definition, those marks I should get. So ama marks with definition avame ukuba 2 marks mostly ku exam. So nabakubuza i-definition ivamise ukuba ne-2 marks. So mina to be sure ukuthi 2 marks leyo ngiyayithola, I first understood ukuthi definition leyo ithini ne, and then after sengiyi-understandile, because sengiyi-understand, then ukuthi ngibe sure ukuthi 2 marks leyo nginayo, vele bengizoyenza sure ukuthi i-definition leyo ngiyibhala njengoba iso. So into engishoko lapho ukuthi nakufanele uyi-cram i-definition i-cram, wenze sure ukuthi uzitholela i-2 marks yakho. I-tip engikunikeza yona leyo. Okay, so if bathi ku-exam state Newton's second law of motion in terms of momentum, you would write the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the resultant force, or in the direction of the net force. Okay, so in symbols, this is F net is equals to change in momentum divided by the change in time. So delta P is change in momentum, with delta T is the change in time. So delta P over delta T is the rate of change in momentum. Okay, so athini lana bathi calculate the change in momentum when a net force acts on an object and its velocity. So if you are given a net force, right, if you are given a net force and time, you can calculate change in momentum. Calculate the change in momentum when the net force acts on an object and its velocity. If you are given a net force and time, you can calculate the change in momentum, right? Okay, siyadlula lapho, and then we go to impulse. So they define impulse as oops, okay, they define impulse as the product of the resultant force, or the net force acting on an object, and the time the net force acts on an object. So the impulse, it's for mina impulse bekuba i-challenge ukuthi ngizwisise, because ayinayo i-symbol ekungeyayo. So the way define i-impulse, so if ngibhala F net times delta T, this is impulse, right? This is impulse, or this is impulse. Okay, so define impulse as, nababuza definition impulse, okay, bengizama ukuhighlighta lapha ayisebenzi. So but it define impulse as the the product of the net force acting on an object and the time the resultant force acts on an object. So from that definition here, Newton's second law of motion in terms of momentum, if you rearrange this formula and make delta P the subject of the formula, you will see that the change in momentum is equals to impulse, right? And then impulse is the delta is defined as the product of the net force exerted on an object times the time the force acts on an object. So this one is a difficult one to understand, right? So if you have a force acting on an object and you know the time that the force acts on an object, then you can calculate impulse, which is equals to change in momentum, right? Lesizoyithola ekuhambeni kwesikhathi masenza ama examples or ama question, right? But then this is the definition. To secure marks, make sure with the definition you ask, right? Define impulse as the product of the net force acting on an object and the time the net force acts on an object. So if you know the force acting on an object and you know the time that force is acting on an object, then you can calculate impulse by taking the product of the two, right? And then this is impulse. F net times delta T is impulse. The impulse ayinayo symbol ejamele. This, when you say this is impulse, right? Okay, so but use the impulse momentum theorem to calculate the force exerted, the time for which the force is applied, and the change in momentum for a variety of situations involving the motion of an object in one dimension. So if you have impulse, you can the impulse momentum theorem states that, okay, impulse is equals to the change in momentum. So if you have impulse, you can calculate change in momentum because impulse is equals to change in momentum, right? Or if you have the change in momentum and you have the time a force is exerted on an object, you can calculate the magnitude of the force that is exerted on that object using this formula here, right? This formula, you can also take it as the impulse momentum theorem, because when you rearrange and make delta P the subject of the formula, uzoba nokuthi impulse is equal to change in momentum. So that is the impulse momentum theorem. Okay. Okay, and then siyaku conservation of momentum and elastic and inelastic collisions. So explain what is meant by an isolated system or a closed system. So in physics, if bubbles are this definition, but what is a closed system or an isolated system? You would say in physics a system on which the resultant force or net external force is zero. So in short, a closed system is a system in which there are no external forces, right? There are no external forces means there's no friction or any other external force that you can think of. Okay, air resistance, friction, and other ones. So in a closed system, there are no external forces, right? So, and then but state the principle of conservation of linear momentum. The principle of conservation of linear momentum states that the total linear momentum of a closed system remains constant or is conserved. That is the principle of the conservation of linear momentum. And then this principle you will use in answering most of your exam questions relating to momentum. So we will have maybe a situation where two objects are moving towards each other and then they collide, and then you will maybe be asked to calculate the change in momentum after the objects have collided, right? Or calculate the velocity after collision or the mass after collision. So a principle lena izo apply in most exam questions. Into ngisho ngileyo. Yeah, the total linear momentum of a closed system remains constant. I will show you how this principle is being applied masses pendula ama questions. Okay, so apply the conservation of momentum to the collision of two objects moving in one dimension along a straight line with the aid of appropriate sign convention. So when you are answering questions relating to linear momentum or questions relating to the application of this principle of conservation of linear momentum, choose a direction, right? And then assign a sign to that direction. Okay. Lana ngithi nawuphendula ama-question we-linear momentum, choose a direction and then i-direction leyo ikhethako assign allocate a sign for yona. If okay ngiphendula ama-question with two objects colliding, ngingathi choose the direction to the right as positive, which means if the object yokuthoma is moving at a velocity to the right, because velocity is a vector quantity, leyo velocity yale object move to the right, I will give it a positive sign, and then if velocity object move to the left, I will give it a negative sign. Okay, so all of this will make sense once we start doing questions or examples, right? Okay, so Lanabati distinguish between elastic collisions and inelastic collisions by calculation. Okay, so an elastic collision is where the total kinetic energy of a system, so the total kinetic energy of a system is conserved during an elastic collision, but not conserved during an inelastic collision. So into ngisho lana ukuthi if I have a kinetic energy before collision and a kinetic energy after collision, if that collision is elastic, then the two kinetic energies must be the same. Okay, again it will make sense once we start doing questions, right? Ukhumbule futhi ukuthi i-kinetic energy, masikhuluma nge-kinetic energy sikhuluma nge-energy that is related to an object's motion, right? If you think about kinetic energy, think about energy due to an object's motion. Kinetic energy has to do with motion, right? I-definition clear anginayo kinetic energy. Okay, so now let us try to summarize all of this, right? My key points. So sithini, we're trying to summarize all of this. So we have momentum, okay, we have momentum and impulse, right? So in this topic into engayisho ukuthi you have to be able to define important terms, right? You have to be able to define important terms. Kumele ukwazi ukudefine momentum, kumele ukwazi ukustate Newton's second law of motion in terms of momentum, kumele ukwazi ukudefine i-impulse, kumele ukwazi ukudefine i-principle of conservation of linear momentum, kumele ukwazi ukudefine i-momentum, impulse momentum theorem, right? So yeah, so must define a momentum. We'll say momentum is a vector, so you have to be able to define momentum, right? Momentum, momentum, hope the spelling is right. So define a momentum, momentum is a vector quantity which is defined as the product of an object's mass and its velocity, right? And then momentum is equals, singular momentum is this one, it's P, it's small letter p, right? Because capital letter P is used for power. So you'll say small letter p is equals to mv, where m is mass measured in kilograms, v is the velocity measured in meters per second. Then the unit of momentum is kilograms meters per second, right? So and in the middle was we define its impulse. So impulse is equals to change in momentum, right? Symbol for impulse, it's the net force exerted on an object multiplied by the time that force is exerted. So this is impulse. So if you see this is impulse. But then we're saying impulse is equals to the change in momentum. So the impulse momentum theorem is this one. Impulse is equals to change in momentum. So if I want to calculate the net force, and then I know the change in momentum and the time that the force is being exerted on that object, then I can be able to calculate the net force, right? That is what the impulse momentum theorem is saying. Okay, then Newton's law of motion in terms of momentum states that the net force exerted on an object is equal to the rate of change in momentum. So mawenza F net is subject of the formula. You'll have in Newton's second law of motion in terms of linear momentum. Okay, so the change in momentum, if delta represents change, right? The change in momentum is equals to final momentum minus initial momentum. And then what is final momentum? Okay, where final momentum is defined as this, right? So final momentum will be the mass of an object times its final velocity. Initial momentum will be the mass of an object times its initial velocity, right? And then change in momentum will therefore be equals to the final momentum minus the initial momentum, which we can pull out we can factorize the mass, right? So this is change in velocity. Okay, therefore change in momentum is equals to the mass of an object times the change in its velocity. Okay. Now now we move to the principle of conservation of linear momentum. So the principle of conservation of linear momentum states that in a closed system is a system in which we don't have any external forces. Where external forces are absent, we have a closed system, right? So the principle of conservation of linear momentum states that in a closed system, the total linear momentum is conserved or is constant, which means that the total linear momentum before collision is equals to the total linear momentum after collision. So this sign is sigma, it means total. So P here is for momentum, and before and after, the total linear momentum before is equal to the total linear momentum after. This is the principle of conservation of linear momentum before, this is the principle of conservation of linear momentum in a closed system. Closed system, external forces are absent, meaning no friction, no air resistance, or any other external force, right? So now when you are applying this principle, this is where choosing a sign is important. So if you say choose the direction to the right as positive, then an object moving to the right, you will assign its velocity a positive sign, and an object moving to the left, you will assign its velocity a negative sign. Okay, so yeah, now we move to the topic of what, not the topic, man, this point here, elastic and inelastic collision, ne? So lapha ngikhuluma nge-kinetic energy nangikhuluma ngama-elastic and inelastic collisions, right? So in an elastic collision, the total kinetic energy of a system is conserved, right? So lapho ngizothi total kinetic energy of a system is conserved during an elastic collision, right? And then but not conserved during an inelastic collision. Okay, so if you remember from grade 10, the formula for kinetic energy is this one, is equals to half of the object's mass times its velocity squared. Okay, and then we're saying kinetic energy is the energy possessed by an object due to its motion, right? Mass and velocity, all of this has to do with motion. It has to do with a moving object. And then the energy, the SI unit of energy is joules, or is it kilojoules? It's joules, right? And then Now, in an elastic collision, we're saying the total kinetic energy of a system is conserved. So meaning before collision, the total kinetic energy before collision is equals to the total kinetic energy after collision, right? So this is similar to the principle of conservation of linear momentum. So in the principle of conservation of linear momentum, we're saying the total linear momentum before collision is equals to the total linear momentum after collision in a closed system. Closed system, no external forces. So similarly, the total kinetic energy of a system is conserved during an elastic collision, right? So lana sithi, the total kinetic energy before collision is equals to the total kinetic energy after collision. So this is an elastic collision, right? If it's an inelastic collision, then the total kinetic energy before collision will not be equals to the total kinetic energy after collision, right? Okay, so yeah, right. So this topic, the way to understand it better, I believe it's by doing as many questions as possible ekuyinto esizoyenza ekuhambeni kwesikhathi. So okwanamhlanje, let us think about these definitions, sizame ukuzwisisa ukuthi achaza ukuthini, and then in the next lesson we'll start looking at examples. Okay, I think that's it for today.